Alright guys, welcome to lesson 5.2. We're going to talk about solving equations that have radicals in them today. And we're also going to talk about how you can find the domain of a radical function, which is relevant. In case you guys forgot, domain is what are the possible values of x, and so that's kind of relevant to when you're trying to solve for x, because it's possible that you want to make sure that the answers you get are actually allowed. You want to make sure that these are x values that are actually part of the domain of the function. So let's go ahead and begin here with talking about domain. So how do you find the domain of a radical function? Well, we talked a little while ago, last lesson, about how, if you have the square root of a negative number, you get imaginary answers, right? But if you have the cube root of a negative number, you get a real number, okay? And so what that basically means is that you can't have even roots of negative numbers, but you can have odd roots of negative numbers, right? And so when it comes to radicals that have odd roots, the domain is all real numbers. X can be anything at all. It doesn't matter. However, when it comes to even roots, the radicand, the part underneath the square root, which is called the radicand, has to be positive. So what we're going to do to find the domain is we're going to take the radicand, we're going to say, okay, it's greater than or equal to 0, and then we're going to solve for x, and that'll tell us what x is actually allowed to be. Okay, so let's go ahead and put this to work for us in an example here so we can bring that concept to life a little bit. So the first thing you have to do if you want to find the domain of a radical function is you got to ask yourself, do I have an even root or an odd root? Now this is a square root. They don't write the number, but when there's no number there, that means it's a square root. And so we're looking for a second root, which means that we are dealing with an even root. Now when you're dealing with even roots, the way that you find the domain is you take the part that's underneath the square root and you make it greater than or equal to 0. Because whatever's underneath the square root, it can be greater than 0, because it has to be positive, or it can be equal to 0, because there is a square root of 0, but it can't be negative numbers. So you just take the part that's underneath the square root and you make it greater than or equal to 0 and you solve. So let's go ahead and do that. So here's my domain. X can be any number greater than or equal to negative 3. So for instance, the number 5. 5 is part of the domain of this function. X can equal 5. But negative 10 is not part of the domain of this function because negative 10 is not greater than or equal to negative 3. And if you've tried plugging in a negative 10 here, you would end up with a negative answer underneath the square root, which is undefined. So that's what our answer is. The answer is x is greater than or equal to negative 3. Let's go ahead and take a look at number 2 now. On number 2, we have an odd root. And when you have an odd root, you don't have any math to do at all. You can just say the answer is all real numbers because whatever's underneath the radical in this case can be any number at all. So there you have it. So here's a student practice for you guys. Numbers 1 and 2. Pause the video and try to work those out. And when you're done, when you unpause the video, you will see the solutions. Now number 3 is extra credit. If you want to try these problems and email your solutions to me, I'll give you some extra credit for them, 2 points each, added on to this homework assignment. You do have to show your work to receive credit, okay? These are a little bit trickier than the ones I'm giving you. But remember, the idea is what is x allowed to be? That's the domain. So, but anyway, pause the video and work on 1 and 2 for sure. And then when you're done and you unpause the video, I will have the solutions up for you. Alrighty, here's our solutions. So number 1, since it's an odd root, the domain is all real numbers. For number 2, since it's an even root, the domain can be found by taking the radicand, 4x plus 8, and setting it to be greater than or equal to 0, and then solving for x. Solving for x gives us x is greater than or equal to negative 2. Now I just want to warn you guys of something here really quick. let's just make a little change here just for fun and just for the sake of discussion. Say this was a -4. All right, so I'm still going to minus the 8 on both sides. And we're still going to divide by a -4. But when you divide by a negative number, I don't know if you guys remember this, but if you divide by a negative number, your inequality flips around. So be careful. If you ever divide by a negative number, you have to flip it around. So now just so you know, that's not the answer to number 2. I changed number 2 just to make a point. But there's my point, is that if you ever divide by a negative, you have to flip the inequality. All right, so now we're going to talk about how to solve radical equations. So here's our steps. So step 1 is if you have any numbers that are not underneath of the radical, we're going to get rid of those first. Then the next step is the main step. We want to get rid of the radical symbol, and you do that by raising both sides to a power that matches the root. So for instance, if you're taking a square root, then you would square both sides. If you are taking a cube root, then you would raise both sides to the third power. Okay, so the idea is that powers cancel out roots. And after you've gotten rid of the root, it's as simple as solving for x. So once again, the steps are get rid of the numbers outside of the radical, raise both sides to the power that will cancel out the radical, and then solve for x. Now there's a couple of other little notes down here that I want to share with you guys. First of all, if you ever have a radical that has an even root and it's set equal to a negative, well, that's a trick question. There's no solution to those because it's impossible for a square root of an even root of a square to ever give you a negative outcome. They can only give you positives. We would say that there's no solution there. Now, unfortunately, if you don't notice that, you're going to go through these steps and you'll get an answer, but your answer will be false because it's not real. There was a false statement in the problem to begin with. Now, another thing to keep an eye out is if you ever have an equation where there's a radical on both sides, which we will see those later on in this lesson, these are ones where it's possible that the answer you get isn't allowed. So for these ones, you'll have to do an extra step to make sure that your answer is allowed. Okay, and I'll talk about how to do that when we get there. But the 3 basic steps I've got illustrated up here for you guys. So let's go ahead and begin here. So let's begin with number 1, of course. The first thing that we want to do is, as I mentioned before, is you want to get rid of those numbers that are outside of the square root. So let's do that first. So what numbers are not, well, it's not a square root actually, it's a cube root. So what numbers are not under the radical? Well, the 5 and the 2. So I'm going to add 5 on both sides. You always do the addition or subtraction first. And now I have that. And then to get rid of the number in front of the radical that's multiplying it, you're going to divide both sides by that. And now here's where the main step comes in. What you're going to do now, the step 2 is the main step. Step 2 is where you're going to raise both sides to a power that matches the index of the root. So in this case, the index of the root is 3. So I'm going to raise both sides to the third power. A third power cancels out a third root. So this and that cancel, and now I'll just be left with x plus 1 equals 6 to the third. So I've got x plus 1 equals 6 to the third. Next, we'll go ahead and minus the 1 on both sides. Now, sometimes they'll just leave the answer like this, but finding 6 to the third power is not all that hard. So we'll go ahead and do it. But you'll notice that sometimes on the answer keys that I have, they'll just leave it like that because sometimes the numbers are so big, they figure, we're not going to figure that out. We're just going to leave it like that. But 6 to the third power is really not all that big. 6 to the third power is only about 216. So it's not that much work to go ahead and just work it out. So the answer for this one will be 215. Okay, so what are the steps again? get rid of the numbers outside the square root, or the radical, then cancel the radical by raising it to the appropriate power, and then just get x by itself and simplify. All right, let's do another one here. How about 5 minus the square root of 2x plus 5? Well, I've got two numbers that are outside the radical. It doesn't look like it, but I do. I've got a 5, and then I've got a 1, a negative 1 to be precise, in front of that radical there. So the first thing I'm going to do is I'm going to minus this 5 on both sides. Next, we need to get rid of the other number that's outside the square root, and that's that negative 1. So I'm going to divide both sides by a negative 1. Now, I have this. Now, first of all, if I want, this is a square root, right? So there's like a 2 here. So what power would I raise this to? I would raise it to the second power. But we have a problem. Do you guys see how I have an even root equal to a negative number? That's not possible. That's one of those ones where you got to watch out for them because there's actually no solution to this problem. It's a nonsensical question. Okay, because a square root cannot give us a negative output. All right, so that is number 2. Let's go ahead and have you guys try some student practices here. Go ahead and pause the video and give each one of these a try and see what you get. When you unpause the video, you'll see the solutions. All right, so here's our solutions. For the first one, you add 2, then you divide by 2, then you raise both sides to the 5th power, and then you minus 1 to get 0 as our final answer. On number 2, first step is to minus the 4. Second step is to divide by 2, which leaves us with a negative 1. Since this is an even root, once again, we have no solution. Don't think, though, that always, that's unfortunately, I wasn't very creative with my student practices here. Just don't think that just because it's a square root, it's always no solution. It's not, right? It's if you have an even root equal to a negative number. So if this was a positive 1, once again, let's just kind of pretend for a second that that was a positive 1. Then you would square both sides. The square would cancel out the square root, and we'd be left with just 2x plus 5. 1 to the second power is 1, and then you just solve that like normal by minusing the 5 and dividing by 2. And I think you'd end up with something like negative 2 as an answer. So, just kind of giving you guys another hypothetical to be aware of there. Okay, now let's go ahead and take a look at a third type of problem. This is one where you have square roots on both sides of the equation. Now, when this happens, we have to make sure that we, for these types, let's write this down. For these types of problems, we need to check our answers. Okay, so whenever you guys are solving these things, after you get your answer, you got to make sure that your answer is actually allowed. Okay, so what do I mean by that? I will show you. So first of all, let's go ahead and do the first one. I'm writing space here for myself. Okay, so in this case, you'll notice that there's no numbers outside of the square root. And so because of that, we're just going to start by raising both sides to the appropriate power. Now, since these are square roots, we're going to raise both sides to the second power. And of course, the square root and the square cancel each other out, so we're left with just the regular old equation, just like that. Okay? And from here, we're just going to use some basic algebra to solve it. So I'm going to put my x's together. Move the 5 over. So I got x equals negative 8. But I need to make sure that my answer is a good one. So how do I do that? You don't have to do it with the other problems we've been doing because it won't happen with those kinds of problems, but with these ones it will. So let's see what I mean by that. Just a second. Okay, what I mean is you're going to take your answer and you're going to plug it in for x on both sides. So get negative 11 there. And negative 16 plus 5 is negative 11. Well, here's the thing. The two sides are equal, right? But a negative is not supposed to be under the square root. So if the number you plug in causes the radicand to end up being negative, then this is not an acceptable answer. That's an erroneous answer. And we therefore say there is no solution to this problem. Okay, so we got to be careful with those. So with these types of problems, you can sometimes end up with an answer that doesn't work. Okay, but that doesn't always happen. It just happens sometimes. Let's go ahead and take a look at number 2 and see if this one works. Once again, we're going to start by squaring both sides. Cancel out those roots. And we talked about how to deal with fractions a little bit earlier this year. What you do is you just multiply by the denominator so they cancel. But whatever you do to one side, you have to do to the other side. So I need to multiply this by 3, and I need to multiply that by 3 as well. So we end up with a total of 48 minus 3x equals x. Then I'm going to go ahead and add the 3x on both sides, which leaves me with 48 equals 4x. And then I divide. And I end up with x equals 12. So there's my answer, but is it allowed? Well, let's see. Let's plug in our answer and see if it makes any of these square roots have negatives underneath. So I'm going to plug in 12 here, and I'm going to plug in 12 here. All right, 16 minus 12 is 4, and 12 over 3 is 4, and the square root of 4 is 2, and we're good. We didn't have negative square roots this time. So this is actually a good answer. Now, I don't want you guys to think that x can't be negative. X can be negative. It's what's underneath the square root after you plug x in that cannot be negative, okay? So don't think that just because you end up with a negative x, there's no answer. That might actually work. It just can't make the whole thing underneath of the square root become negative once you plug it in, all right? So let's go ahead and have you guys try one. Here's 2 problems for you. Go ahead and pause the video, and when you unpause it, you will see the solution. All right, guys, so here's our solutions. For number 1, it's 5, and for number 2, you would have gotten negative 2, but that makes the square roots become negative, so that's a no solution problem. Okay, I'll let you guys study that if you need to, but I'm going to move on. All right, one more type of problem here. Radicals that result in quadratics. Now, just so you guys know, you also need to check the answers on these. Okay, you also need to check the answers on those. Is it's possible, once again, you can end up with an answer that's not allowed. Okay, now notice the title here. This one is called Radicals that Result in Quadratics. So you'll see what I mean as we go through the problem. So in this case, we have a radical that's equal to not a number, but a variable. So whenever I square both sides, I actually end up with this. Now that's a quadratic. Anytime you have an x squared, you're dealing with a quadratic. When you want to solve a quadratic, you need to move everything over to one side. So I'm going to put the 5x over here and the 6. And that way on the left side now we just have 0. And we can solve this using the quadratic formula, which we learned back in chapter 4 or unit 4. Okay? So we do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I'm not going to be showing my work as much here because this is stuff we've already spent time on a while back, but I'll show some of my work. So I end up with two answers, 6 and -1. But now we have to make sure that both of those are okay. Okay? So don't be surprised when you get two answers with these ones. It's possible. But you have to make sure that they're both okay in the end. So let's go ahead and plug them in and see what we get. So I'm going to plug in the 6, and I'm also going to plug in the -1. Okay, so, oh, I forgot to plug in the 6 over here. There you go. So I just put 6 in for the x on this one, and then I put -1 in for the x on this one. Let's simplify it. So this is 30 plus 6, which is 36, and the square root of that is 6. So we're good. For the next one, we have 5 times -1. That's -5. And -5 plus 6 is 1. And the square root of 1 is not -1. So that one is not a solution. Okay, so we really only have an answer of 6. All right, and so that's how we will check our answers. But anyway, I'm going to let you guys go ahead and try one of these. Let me pause the video here and move you onto here. Go ahead and give that a try. Pause the video, and when you unpause it, you will see the solution. All right, squaring both sides, we get this. Moving everything to one side, we get the quadratic equation you see here. So we use the quadratic formula, and if you work it out correctly, you'll get 5 and 2. And both of those numbers work. If you plug in 5, you don't end up getting a negative under the square root. And if you plug in 2, you don't get a negative under the square root. So both the answers are good this time. All right. And that concludes our lesson on solving equations with radicals.